Hey, hello there. Today's Leetcode challenge question is called Permutation Sequence. We have a set of n different numbers. For our convenience, it's actually 1 to n. We want to consider all the unique permutations we can do with this set of n numbers. So it's n factorial in total. Because for the first position that we decide a number, it will be n choice. The second position, it will be n minus 1. All the way to the very last position, we just have one choice. So multiply those together, we get a factorial. So that's the number of permutations we can do with n numbers. If we sort those permutations in the lexicographically order, from the smallest to the largest, giving example where n equal to 3, we're dealing with number 1 to 3. The permutation sequence in the sorted order will be 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2 3, 3 2 1. So if we actually obtain this sequence of permutations, we want to find the case one from the sequence. So if we actually just generate all those, we can just directly take the case one from the list, from the sequence. But it will be really time consuming and the space inefficient to actually generate all those sequence. And to think about it, n factorial subtract 1 sequence is totally useless in our case. So we want to find a way to directly generate the case one. So how are we gonna do this? We want to try to look at the permutation sequence and look out for patterns. Now we're dealing with n equal to 3, and we see that there are distinct 3 different groups inside the permutation sequence. They are indicated by the first digit here. So the first group of size 2, their first digit is the smallest among all the choice we can do at the time, 1 to 3. The second group, they all start with the second largest element we can choose from the set of numbers we can do. The very last group, it's starting with the largest one. The reason that they are grouped in sequence is that if the first digit starts is 2, the second largest one, it has to any sequence that we can form with the smallest number has to come before that. So how many are those? If we fix the first digit, the remainder problem basically is n equal to 2 problem. So the total choice for that is 2 factorial. So it's 2. So that's telling us the permutation sequence are grouped in different groups indicated by their first character, and the first character or first digit, first number in that sequence is sorted order. If we just want to group this group all this sequence by the first character, it will be 1 2 3. That will be in the sorted order as well. So this tells us instead of generating all those, we can try to do this one number at a time. So if we're looking at k equal to 3 here, it's larger than 2, so it's definitely not in the first group. It's smaller than 5, so it's definitely not in the third group. The only group it can belong to is the second one. So we can make sure, we are sure that the first number in this k sequence that we're requiring, it's going to start with 2. So we can just iteratively figuring that out and populating this required sequence one number at a time, all the way towards the right. So it will be a divide and conquer kind of pattern here. So just a little bit concretely, what we're going to do is for a given size n, we want to calculate the group size. So here it's 2 factorial, that's n minus 1 factorial. And use the relationship between k and the group size to figure out which group it belongs to. If it belongs to the i's group, the first character for the k sequence we're looking at is going to be the i's smallest element number we can choose at that time. And once we made this choice, we exclude this number from the available numbers, and also updating the k, because the k now should be the new k for the problem that's one size smaller. What's going to be the new k? It's going to be the k that we skipped the first number of groups that has the first character smaller than our. So we skip some of the all the groups that's before us. So that's why we subtract the prior group number of prior group multiplied by group size from the k to update this to be the new k. Then the problem become a n-1 problem with the updated k, and also the updated number choice we have. So basically we're just going to maintain the three things and iteratively shrinking them, while at the same time each time we shrink the problem size smaller by one, we adding one more digits to the sequence we are building out. So it's just going to be looking like that. So let's just start code this problem up. So obviously we want to generate n numbers, so it's going to be a loop running n times. And so the first thing we do is to calculate the group size. Let's just call this group size. It's going to be factorial. Maybe we will store the pre-calculated factorial number ahead of time, or using some function. It doesn't really matter. Which is going to be n-1, and the choice about the group identifier number and the new k is going to be the doing this division modular between the current query k and the group size. Let's just call this size S then, or I can just put it in here. So if we have something that holds the result, we will basically append the i's smallest choice that we have at this time to this result list. And actually, once we put it on there, we have to pop it out from the available numbers, because it's being used in the subsequent step. We can no longer use that number. So it's let's call this digits something. In the end, we just stitch together this thing to be a string again. Yeah, all they're left is basically populating these digits and the factorial function. Here it's just yeah, for convenience we have just 1 to n, and for the factorial it's starting with a 1, and we're populating up to n-1, because n-1 is the largest one that we will be getting from here. We're just iteratively appending the number multiplied by the last factorial number. So that generates the factorial array. So 3, 2, 1, 0. So should I be n-1, right? So this will still run. This will not run when it's 0. So if it's 3, it will run 3, 2, 1. The first time it will skip up. So yeah, it's n. Yeah, let's see if it works. Nope, we are generating 2, 3, 1 instead of 2, 1, 3. What's the problem? Oh, it's the k here is indexed from 1, so I should just decrement k by 1. Then I think we are good to go. Yep. Is it accepted? Okay. So yeah, so this is the code. It's the divide and conquer approach. We noticed that the sequence are sorted the the permutations in the sorted sequence are grouped together. And for the lines we're looking at, we're gonna just have that many corresponding groups to the n we are looking at. So based on the relationship between k and the group size, we can figure out the leftmost card and reduce the problem size to be one smaller, but still the same problem. So that's the code. It's pretty. It's not difficult today, surprisingly. All right, so that's it for today.